Hi, everyone. Happy to be here and happy to present our wonderful co-panelists with whom we will be talking about scaling solutions, layering versus sharding for the next 40 minutes. I'm Kristina Lucrezia, Managing Editor at Cointelegraph, and here are my wonderful co-panelists. Let's start with the women first, Hsiao-Wei Wang, who are researcher at Ethereum Foundation. Nice to see you.
Nice to meet you.
Augusto Teixeira, founder and CSO at Cartesi.
Hello, nice to meet you. Pleasure to be here.
Anton Adler, co-founder of Fuel Labs.
Hello, everyone. Thanks for having me here.
So I would like to ask everyone to present a little bit what are you working on right now and what is your role in the developing of solutions for scalability of blockchains? Whoever wants to start first. Maybe in the same order.
Cool. Hello, everyone. So I'm Hsiao-Wei. I'm from Ethereum Foundation research team. So we are the researchers to maintain and design the ETH2 spec. So in Ethereum 2.0, aka ETH2 Serenity, and so we have different phases to get all together of the Ethereum 2.0. So we have different phases about ETH2, and as you all know that Moderator testnet has been launched a few weeks ago, and we are planning to launch phase 0 this year. I think so. And the next stage will be the phase 1. Yeah, phase 1 is all about the shard data chain. So in this phase, we will introduce the sharding to the ETH2 ecosystems. So about the ETH2 sharding, it's the quadratic sharding. So with the random beacon chain that will be introduced in phase 0, we will have the ability to produce the on-chain pseudo random number on-chain. So it will help us to pseudo randomly shuffle the current validator set to select a small set of the validators, and this set of validators can represent the verification community, committee of a certain shard block. So by this random shuffling algorithms that, and also we have the honest majority assumption. So with enough number of validators, we can have the enough security to prevent the system from manipulated by the attackers. So that's what the sharding is, and the basic idea is that like this. Yep, thank you.
So we delve directly into the issue. Thank you very much, Al. So we know already that you are from the part of sharding. Okay, let's pass to Augusto. Tell us a little bit about your project.
I think you're muted.
I'm sorry.
Yeah,
Can you hear me now? I'm sorry. So I'm Augusto. I'm working at Cartesi. We are a layer 2 solution on top of Ethereum for now to improve on the scalability issue. So before I talk a bit more about what are the pieces we're trying to tackle, let me talk a bit about scaling, which is a problem that everyone is worried about for a long time. It's a bottleneck on Ethereum and every blockchain that cares about decentralization. But it's a multifaceted problem. So we have, for example, the number of transactions per second one wants to achieve, or how much computation can you do in each transaction, or what's the latency, or how much data can you put. So there are several aspects to it, and that's why you see such a flourishing ecosystem of different projects trying to tackle different aspects of this problem. And we are working on computational scalability. So we are now, we have launched our SDK, so we are able to make transactions that are fully decentralized, but they are very intense in terms of computation. So one transaction, you could launch an operating system, run Linux, run a spreadsheet, do several things that are normal for a computer, but are very costly to be made into the blockchain. And the technology we use behind is called interactive verification. It's an algorithm that is famous from the 90s. So there are other projects that are going to tackle, transaction throughput, number of transactions per second. And my view, at least, of the future of scaling is that all these projects will interact together and become a super machine that is not anymore worried about scaling.
Very interesting image of the future. Thank you, Augusto. John, what about you?
Sure.
Which path will you take?
I guess I'll have to go with the layer route, but if we need me on sharding, I can always argue for sharding. But anyway, so I'm working on two projects. One of them is Fuel Labs, which is Ethereum focused. So it's we're building Fuel, which is a highly scalable optimistic rollup that uses a different execution model than, for example, the EVM. We're focused on using the UTXO data model and execution with things like stateless predicates, which allows for much greater transaction throughput without increasing the cost to run a full node. So that's one thing I'm working on. The other thing I'm working on is Lazy Ledger, which is a new blockchain that is specifically engineered to be optimized for data availability throughput. So it uses the intuition behind it is uses the paradigm of separating data ordering and availability from execution. So it uses the blockchain just to timestamp messages, just to timestamp data blobs, and then all the execution can happen on this ordered and available data client side, which is in some ways very similar to the paradigm that rollups are using, right? Where execution happens off-chain, but you use Ethereum to order data and make it available. So those are kind of the two things I'm working on.
Wonderful, guys. Okay, so we have kind of two different camps, and also, well, John, you can be a little bit in the middle, helping to develop different paradigms. Guys, if we're talking about advantages of different solutions, and maybe we can take about challenges at the same time. If you can enumerate the advantages of the solution that you have been developing, and talking a little bit about the obstacles that you've been encountering on your way, that would be really interesting, and maybe you can discuss it, interact on every point altogether, because I'm very fascinated to hear your opinions on how do you deal with different issues. So let's start with you. How would you name the main advantages?
The main advantage, I think, so I do think that layer 1 and layer 2 layer can help each other a lot, but the main advantage of the layer 1 solution is that it is secured by all the validators who joined the protocol, I think. So compared to layer 2 solution that only selected community or company to support that layer 2 solutions, I think security is the main advantage here. Yeah.
Nice. What about challenge? What is the biggest challenge?
So the biggest challenge, you can see what it is in ETH1. So why we have to implement ETH1 and ETH2 in parallel is that the core protocol changes is not easy to make community altogether to upgrade the core protocol. You need hard folks or soft folks. Mostly hard folks, it's very difficult, or like because we worry about security very much, so every hard fork should be fully audited and fully tested. So it's less likely to have the very overhaul of the whole systems in ETH1 currently. So that's why we think design ETH2 could be more efficient. Yeah, that's the challenge.
We'll get back to the issue of security for sure. Augusto, the floor is yours.
So yeah, when I see the layer 1 and layer 2 playing together, as Hsiao-Wei said, so we are going to benefit mutually from each other. So we are working on layer 2, and every improvement that happens on layer 1, be it usability or scalability, even stability of fees, everything that happens on layer 1 has a direct impact on us. So sometimes we cancel a route because we think, okay, the cost of fees in layer 1 could keep growing and make that route not very feasible. So if sharding helps with that, it's definitely gonna open new routes for us. On the other hand, it's clear that sharding alone cannot take the heavy lifting if Ethereum wants to be, the new platform for what now only centralized solutions have a role. So for example, if it wants to be the new Amazon, new Uber, so it needs some heavy lifting that cannot be sharded away to the edges of the network. The edges are going to help. The sharding is going to be fundamental, but some things will have to be away from the consensus protocol, and then we go back to the consensus protocol only in the case of disputes, only in the situations of conflict or misbehavior. So in talking about advantages, I like to think of this scaling solution in parallel with the scaling of hardware that we saw boom in the 80s. So at that time, people were developing very fast crystals. So computers went from 10 megahertz to 2 gigahertz in very short period, and also going from one core to several cores, graphic cards, fast memories, all these were solutions that were trying to tackle different aspects of the hardware limitations at the time. And now we have a very clear understanding of what good hardware is. If you go to a mobile phone store and you buy the cheapest possible phone, it's going to come with all these solutions built in: graphic cards, multiple cores, RAM, layers of caches, everything. And I think that at some point you go to your blockchain solution, it's going to have all these solutions built in: plasma, rollups, zk, zero knowledge rollups, interactive verifications, all of that, and join it together and working for a scalable system. And in terms of challenge, I think these solutions are developing very fast, and I'm very excited to be in this field. But given the security issues that Hsiao-Wei mentioned, developing is very slow, and it requires a lot of attention. And when you start to merge these pieces together and try to make them work in tandem, this is going to be a major exciting challenge, so to say.
I like this point very much. The convergence, and at the same time, the fact that we are still at a very young stage, and this creates challenges as well as opportunities. John, what would be your view on this?
Sure. So in some ways, I'm going to agree with both of my fellow panelists here, in the sense that building out layer 1 scalability, especially in the form of sharding, is important. And also layer 2 scalability is also important. So the reason for this comes down to what kind of guarantees each system can provide, I think. So in terms of layer 2, you can't really have the same guarantees that you can get out of layer 1 for one very specific reason. And that's if you have some smart contract system, it could be a rollup, it could be a sidechain, it could be whatever Cartesi is working on, which is, I guess, some sort of variant of sidechain, or some sort of interactive computation layer like TrueBit, what have you. Ultimately, the kind of adjudication of this protocol must happen within a smart contract. And unfortunately, you can't upgrade a smart contract without introducing some sort of reduced trust guarantees, right? Even if you have something like a DAO, well, now the entire integrity of the protocol relies on this DAO being honest, not on the computation being correct. So you can't really upgrade a smart contract without introducing these issues. And this is something that layer 2 has and layer 1 does not. You can upgrade a layer 1 blockchain without a DAO, right? You just take a hard fork and you do whatever you want. You get the community together and you can change the blockchain however you want. And it's not just changing it for whims, it's changing it so you can do things like fix bugs, fix denial of service vectors, and so on. And you can't really do this in a layer 2. So because of that, layer 2 kind of fundamentally has this issue of upgradability that layer 1 does not have. On the other hand, layer 2 can do nice things. For example, have really, really high throughput or huge transactions, computation that you really don't want to be doing on everyone's nodes all the time. And you can make that trade-off on layer 2, which you can't do on layer 1. So there's kind of a push and pull here that each layer has its trade-offs and benefits that the other layer you don't really want to be doing. And they both have their applications and they both have their places, in my opinion.
Xiao, would you agree with all this anti-sharding arguments that were just mentioned? And do you also support this idea of interchangeability between different layer 1 and layer 2 solutions, and they're working one on another and vice versa?
So I think for example, I think some roll-ups can be fully benefit from shard data chain, even if there's no state extrusion in phase 1. So in phase 1, there's no transaction to let you to transfer the Ether from one account to another account in phase 1. So, but block proposal can put a piece of data on chain. So this functionality can benefit the roll-up solutions very much in phase 1, because the roll-up operator, they only have to push that part of the hash result to the layer 1 chain. And so most, like John said, that the most layer 2 solutions, they will have to found a way to update the contract, and that's the pain point in. I mean, it's also a pain point in layer 1 in somewhere as well, I think, because the code protocol is not that easy to change. But I think you can say it's fairly that. So if some layer 2 solution is somehow just broken, then there's no way to fix it with community consensus, I think, in my opinion, at this moment. Like, you can ask community to hard fork and to help you to fix the 2 solutions for most cases. But if it's somehow bad thing happen in the core protocol, the consensus protocol, then it is still a bug that we have to fix anyway. So yeah, and the security explore that point and how the developers can fix it. The ability is different from it. Yeah.
All of the community is incredible, very important. Augusto, what would you tell about the role of community in
So yeah,
developing scalability issues?
the community is another dimension of this discussion that is very interesting and difficult. So all the projects that are now coming at layer 2 like us can look at what happened in the past with layer 1 ecosystem bubbling. So you can learn a lot from them. We get involvement of the community a lot, and we do things in steps that I think are necessary to make the things safe from the governmental side. So we don't want to have, so that's one advantage of layer 2. You don't have to roll the whole structure to launch the whole structure at the same time. With layer 1, there is the problem that consensus is either there or not there. You cannot put something that's half in layer in some previous layer and half in the layer on top. It's bootstrapping. You have to do everything in one take, and that requires a lot of decisions that the community sometimes is not, able to engage. So that's why it was very complicated for layer 1. Now in layer 2, we can do things much slower. We can say, okay, this part now is going from layer 1 to layer 2, and this another piece and another piece, and then we can feel what the developers are interpreting and what the community is interpreting, and take decisions in a slower pace. So that's the plus side, which we can do things slower. On the negative aspect, I have to agree that if when we find bugs, we have to have kind of predicted them in certain way to be able to roll them back and to fix them. So we have to put things in place that are waiting for bugs to come before, so that we can patch. Otherwise, you are in a very dire situation where you found a bug, but the layer 1 cannot stop to help you. Of course, they're not going to fork layer 1 to fix a bug in layer 2. So you have to have this infrastructure programmed in layer 1, this upgrading infrastructure. And upgrading is always a community topic, right? You always have to engage with the community to talk about changing smart contracts and changing, for example, how you deal with the economy of your solution.
Yeah, very interesting. How would you evaluate the way that the community had taken together with the developers of different projects in these recent years? Well, it's been out of the youngest stage, we've been experiencing development of the market on an incredible scale. How did it impact the community? And well, I imagine that you've been guys for so many years within the community. So how would you? What is your opinion on how did it change during this last years? John, maybe you.
You mean what do I feel about the community changes recently, or for
Yes.
scalability or generally?
Yeah, well, their interaction with the discussions of the scalability issues, but also on maybe on more broad topic in general, because well, community is the reflection of the technology that has been developing. So it's something that is developing together with the technology itself, community and the technology. That's why I'm very interested in your take on that.
So I think I can talk about the ETH2 development community especially. So I think we or have to, thanks to Danny Ryan, who did a lot of work to communicate with different teams and the users who pay attention to the development process. So it's currently, I think we still have about maybe 5 to 7 teams that are working on the core protocol or kind of implementations of the ETH2. So the core, our biweekly core is currently around like 40, at least 40 people will attend the community call. It's quite a large quite a large of small community for the development. I think maybe the people who are working on ETH2 are, maybe it's more than ETH1 core team currently, or they're similar. So I think it's, the communication is a big point for, I would say, Ethereum Foundation. We made some changes that I think you can see. We have more block announcements this year. It's much more than the last few years, and to make communicate with the end users, like how it is really going on. So transparent is a good important part for it, I think. And I hope that in the next few years that the communication channel won't be one way, it should be two-way and more frequently.
For sure, totally agree with that. John, what would you add?
At least, I mean, I don't really have much to say about the community on the ETH2 sharding side, because I'm only tangentially involved in that.
Community in general, I mean the blockchain community.
Yeah. So I guess. Yeah, I guess in terms of two things, one being, in terms of scalability or layer 2 solutions and so on, and the other one being community in general. So there has been, I guess, a slight uptick in more rigorous analysis of the security and trustless and whatnot guarantees of layer 2 solutions. That wasn't really happening a few years ago. That is happening more often now. Which is nice to see. So there's kind of like a burgeoning, but still fairly small research community around, the guarantees that layer 2 solutions provide, how to design incentives, and so on. And I find that it's mostly orthogonal to, and mostly disjoint from the community that has kind of risen out of things like yield farming and the DeFi community, which is not inherently a bad thing. It's just different. There's not really a large overlap between those two systems or those two communities, from what I can see. And in terms of which one has had more growth, I think it's inarguable that the DeFi community has had a pretty obscene amount of growth over the past two years or whatever, as a huge number of DeFi protocols that are atomically composable have been deployed to Ethereum.
Wonderful, interesting. Augusto, would you have something to add about the community?
I think the community has clearly matured a lot. So it's an environment that, so the community is very exciting. The community that builds this decentralized universe. So it's composed of very ideological people. So people who believe in decentralization and the replacement of centralized and dictated solutions, but it's also composed, it's not a very homogeneous community at all. It's composed of people who are there for speculation and trying to sometimes favor one project with respect to another for gain. Sometimes in a positive way. It's not necessarily speculation is a bad thing, but sometimes you have money at stake in one solution and you try to paint it in a different shade. You also have the community of miners, which is of course, vital for the whole system to run. And this is going to have a huge shift when you start to have ETH2 with proof of stake. So all these players are mostly aligned. I would say that all of them want decentralized solutions to strive, for the apps to get adoption. So that's what we should center on, the aligned interests. And from time to time, you have some um, collisions, some group wanting something, some other group wanting something else. And this, okay, has to be talked through. But I think the community has matured a lot. So in the beginning, projects were dictated by very few people because they were the only ones that actually understood what was going on. Then it became, it was rolling down to groups that were overseeing the development. And now it's actually very intense in the community. If there is one proposal happening in the headquarters, it goes to Reddit and it gets evaluated by essentially everyone. So you have a very big peer review of every proposal that comes. And I think this is becoming very mature and very healthy.
Yeah, totally agree. And also the number of developers in blockchain is growing, and that's fascinating. And well, more people are working on these issues. More great technological development we have. We will have experienced something that we maybe haven't yet even conceived about. John, my next question will go to you. I'm sure that you will have something to say about this. What is sustainable scaling, and how would you evaluate the importance of this concept for the whole blockchain industry?
Sure, I can give a brief description of what I think sustainable scaling specifically is. So there's an unfortunate kind of conflation or confusion around state and history. So the blockchain history is just the list of transactions in all the blocks. It's all the previous blocks. The blockchain state would be, in Ethereum, it would be account balances and contract storage. In Bitcoin, it would be the UTXO set. And all nodes need to keep the full state around, barring stateless clients, but that's another story. But all nodes need to keep the full state around. You can't prune it. You can't discard it, because if you don't have the full state, you can't validate a new transaction. But nodes don't need to keep history around. The other difference between these two things is that in order to validate a transaction against state, you usually have to do random accesses against the state, mostly because state elements, like accounts, for instance, are usually hashes of something, and therefore they follow some presumably uniform distribution, and then just random. So it's not sequential. Because of this, you have to do random accesses, and if your state is too big to fit in RAM, which in the case of Ethereum it is, for ETH1 the state is around 60 gigabytes. There's no way you're fitting that in RAM in a modern, like a retail laptop or whatever. So you have to go to disk, and as soon as you're doing random accesses on disk, then goodbye performance. So this is kind of, and the other side is history, which is you just store some transactions on disks. You never do random accesses against history, you just store it on disk. So history is much, much cheaper and much more sustainable than state. And therefore, we ideally want to make using history very cheap and using state very expensive comparatively. And this is especially true in some sort of consensus critical process. So the base layer should ideally, like, let's say Ethereum, the base layer should ideally be, very expensive state, very cheap history, to encourage people to move state off chain in any way possible. And this could take the form of rollups, it could take the form of sidechains, it could take the form of channels, however you want. It just, any way to move state or move the cost of running a node, move it from state and put it into history some way, or even put it off chain entirely. And if we can do this, this is the direction of sustainable scalability, because history is very, very cheap and it can be pruned, while state is very expensive and cannot be pruned.
fascinating, very interesting. Okay, I think we are moving to the last question. We have last 5 minutes. So I would like to get back to this antagonism of layering and sharding, and try to place it within our famous trilemma of decentralization, security, and scalability. Do you think there is a difference? Do you think there is a different impact on the whole balance of a truly decentralized, secure blockchain network if we talk about different scaling solutions? Xiao?
I think it's a bit difficult to define what is folly. It's really just depends on the use case, I think. So for example, if it's easy to think, so the security is different if I want to transfer $1 or 1 million. That would be different trade-off for me personally. But in the end, that is the blockchain. So in proof of work, the blockchain finality is in probabilistic, because the finality is not real. It's not a certain number in proof of work world, but in proof of stake, that we at least we have a certain finality for the canonical shard chain in each two if it's fully executed. And also another question is about what is the fully decentralized. That's also very hard to make it concrete for every user, I think. But I think we will have a best. At the end, we will get to the best point that makes like almost everyone happy. That would be my answer right now.
Yeah, well, thank you. Also, fully scalable is not a good combination. So I'm sorry about the word fully. It's something that I took definitely from some journalistic texts. But yeah, Augusto, secure, decentralized, scalable blockchain.
So I will run the risk of overusing my analogy with hardware, but I like to emphasize that at some point people in hardware development said, okay, it's impossible to go over a 10 gigahertz. So that's, Moore's law is doubling every 2 years. Things are getting very fast, computers are getting very fast, but at some point it will not be able to transpass this limit. It's a physical limit. Physicists were saying that. But the industry can't stop. It has to innovate, and we are still following Moore's law essentially up to today. So of course, physicists were correct. There was a limit to how much you could accelerate the processor, but you could do other things. So let's try to see what could happen in blockchain. So of course, there are statements that you could make 5 years ago about what are the trade-offs that you cannot join together: security, scalability, decentralization. But is a user willing to reduce its decentralization of a given transaction or the security of a given transaction? If you're trading a crypto kitty that costs $2, are you willing to reduce a bit the security and do this in a delegated proof of stake system for reduced taxes? So there are other solutions that sometimes give you a 100-fold increase in something. So some roll-up solutions are not violating anything in terms of this trilemma, but they are giving a 100-fold improvements. And for example, in the original statement about this trilemma, there were no considerations. For example, like can you outsource things and get back to the first layer and verify that things that were done outside were correct with very little effort. So this is one thing that is, borrowing from a bit of a cryptographic miracle, So you could do things that violate the trilemma without violating the trilemma. Just because you have a tool that is a cryptographic miracle that allows for such things to happen. For example, in Cartesi we can do these things like run a very complicated computation that would take decades to run on the EVM in the current gas limits, and throw it in the blockchain and have it verified if need be with 20 interactions. So it's something that was not in the original claim that some things are impossible, because people innovate. So I think that's going to be the solution. People are going to innovate their way out of the trilemma.
Wonderful. I think we can end on this note. John, that's my very last question to you, just to wrap it up. So layering or sharding?
Both.
Perfect. That's what I wanted to hear. Thank you very much. I've learned so much from you guys during this 40 minutes. Thank you very much for the organizers of the conference. And thank you. See you later.
Thank you, Kristina. It was a
Thank
pleasure.
for having us.
Thank you very much.
Have a great day. Bye-bye.
You
Bye.
too. Thank you so much. Stay safe.